Hello, welcome to Math for All, where we try to make math creative, curious, inclusive for everyone. I'm Molly Vokey.
And I'm Heidi Sipnani. Thank you so much for joining us this evening. We're really excited to have you here. If you are interested in following and knowing when we have new shows coming on, you can always follow us on Twitter, Facebook, and our YouTube channel, Math for All. And we are just really excited about today's guest and our major question for today.
Yeah, this is super good timing. We have Christina Tondevold on with us today, the recovering traditionalist, and she is going to talk to us about math fluency and how we can build that. So we're super excited about that, and she has some very exciting stuff coming up. So let me read her bio. Christina Tondevold is a recovering traditionalist. She previously taught mathematics traditionally and expected the students to parrot back what she taught them. Now she gets to work with teachers in developing students' mathematical understandings in ways that are not limited by the traditional ways of doing and teaching mathematics through her site buildmathminds.com, where you can get PD at your fingertips. So let's bring her in. Hello. Welcome. Thank you so much for making time for us. We know that your life is crazy.
Everybody is.
No, that is true. But you're in a particularly crazy stage of parenting, so we get it.
It's going to get better, but I hear it just gets busier and busier as they get older. But at least it'll be helpful when one of the kids is able to drive. That will be really
that gives you and them a lot of freedom, but then it brings on more things about the worrying factor and that kind of thing. I have 2 drivers and almost 3, which is crazy. But it is nice. I do have more time to myself now. So, it's nuts.
So we always love to start with finding out a bit more about our guests. And so we would love to know what your math story is.
My math story is I kind of got into math for all the wrong reasons. I actually went to college to be an interior designer, and first semester when I had to take an art class and realized I was not good at drawing, I basically decided to change my major. I did not have a growth mindset back then. There was not talk about, you're not a good drawer yet. It was like, you're not a good drawer. You should this isn't going to be
get a new career
best for you.
Beat it, girl.
Yeah. So at that point I thought, well, what am I going to do besides that? I had kind of had that set in my mind. And my mom was a teacher. She was a middle school teacher. And so I just by default thought, well, I guess I'll go into education. And my senior year, when we were doing our student teaching, we were one of the groups who was doing something new, and we did a year-long student teaching.
How cool!
And it was a great experience. And I requested to be at a junior high. I'm elementary certified, but my mother was a junior high teacher. So I thought, well, I'm going to be, I want to do what my mom did. I'm going to go teach middle school English. That's what my mom taught. And so my first quarter, there were 4 of us in a junior high setting, and we were all at the same junior high, and we rotated around, and each quarter we got to teach each subject. So I did a quarter doing English language arts, a quarter with math, science, and then social studies. And so my first quarter was English. And after I did that, I thought, I don't want to teach English. I don't like it. I don't like how many papers there are to grade, how subjective it is. Why do I need to change this piece? And then when I got into my rotation and I got to the math teacher, and it was so clear cut, there's a right and wrong answer. And the teacher, it was back in the day where the teacher sat in the front and read off the answers to the homework. And you had, you traded your homework paper with somebody else. So they graded your paper for you, and then you hand it back. And then the teacher would have you call out your grade that you got, and she would be at the computer entering in the grade, right? Do you guys remember these days?
Oh, yeah.
I do remember them, but so now they seem so shocking, right?
I know, right? Because everything that we used to do that was so horrible. And that's why, and I said I got into it for the wrong reasons, because that was the image of a math teacher that I had, and it was the math teacher that I had my entire life growing up as well. That's what math was the teacher would, every day you would start off correcting your homework, going through that, and then you give the grade to the teacher, and then the teacher would stand up and at the front of the class and give the notes, basically tell you step by step how to do it. And then you go practice that. And then you do the pages out of the book where you got 50 problems, and then you would grade those. I mean, it was so easy from my perspective. I'm saying it incorrectly to what it should actually be like. But from my perspective, I thought math is the easiest thing to teach. You have a right and wrong answer. The kids grade it themselves, and then you just put the grade into the grade book. How easy is that? So I started thinking when I graduated, I wanted a job that was math or science. I also enjoyed the science as well because it was so interconnected with the mathematics. I really loved teaching science, but ended up getting a job teaching middle school math. And from then just fell in love with teaching math. But to be honest, my first probably 5 to 7 years of teaching was still very traditional. I modeled after what I saw, which was just what we had talked about. It was stand and deliver style of teaching, of where we just tell them what to do and we just expect them to parrot it back. And then if they didn't know, when they were doing that individual work, I would just, crouch down beside their desk and talk to them one-on-one, but basically say the same thing that I had said in a whole group setting, because I didn't know anything else. I knew the steps and procedures of mathematics, but I didn't know how to help them understand it. It's just like, this is what you do. And I found as I've learned more about myself, I realized that's one of the reasons why I liked math so much, was because I was a good rule follower. I still am a good rule follower, and math was taught as a set of rules to be memorized. And so I always felt like I was good at math. But as I have grown up and learned more about it, I realized I was good at arithmetic. I was good at the operations, but I really had no understanding of mathematics. I wasn't good at problem solving. I was also the kid who I would do the 30 to 50 problems that the teacher would give us, and then I would skip the 1 or 2 story problems, that were always at the end of the textbook. Yep. Because
Which is kind of funny, because you could have just done exactly with those numbers what you had previously done.
That's true, right? Because if we just did 50 problems on addition, bet your bottom dollar that story problem, you just needed an division out with no addition, right? Yeah. But I didn't realize that as a kid, and every once in a while they were a little more complex than that too, because they would make the story problem sometimes, multi-step or throw in some extra stuff in there. And I just was like, I'm not going to waste my time doing this, because I know I just got those 50 problems, right? So who cares if I miss 2, right? I don't have to spend my time on those. So it wasn't until, and this is, I have fell into everything that I have done all for the wrong reasons, typically all for the wrong reasons. I went back and got my master's degree, not because I wanted to learn more, because, I would love to say, the kids were really struggling and I didn't know how to help them. So I realized I needed to do something about that. Now, I went back and got my master's degree because I was teaching in Oregon and they require it for your next certification level. You have to get a master's degree. So I went back to school, and thankfully, it worked out all in, for good things. And I learned along the way a lot of, I just did not know what I did not know. And I did not know a lot. So I got accepted to Boise State University. I live in Idaho. I grew up in Idaho. I taught in Nevada and Oregon and had the chance to come back to Idaho to get my master's degree. And so that is where everything turned for me. I went for the wrong reasons, but it was a big turning point in my life and my relationship with mathematics. I had a supervising professor who had been trained in cognitively guided instruction and opened my eyes to a new way to view mathematics. And even though I was, in my eyes back then, I was a middle school teacher. Like I was a middle school math teacher. I wasn't, I didn't want to work with kindergartners, all of that stuff. And my supervising professor was actually a high school math teacher. And he said the best thing that ever happened to me was when I was I don't remember if it was his master's or his doctorate, but it was when he was learning about CGI, whichever degree that was of his. And his supervising professor said, "You are working with kindergartners," right? Awesome. We start to think I work with 7th and 8th graders. Why do I need to, work with kindergartners? And so really delving into that early mathematics and early numeracy stuff really opened my eyes into what the middle school kids were struggling with, right? Yeah. Like they had no number sense. And so as much as I would try, then even as I went back after I got my master's degree and I started learning, if you're not familiar with cognitively guided instruction, it's all about giving kids a problem in a context. This is the short version of it. It's way more in depth than this, but you give kids a mathematical context and then let them solve it in whatever way that they can. And it lets you see their thinkings, their misunderstandings, and gives you ideas about how to build connections for them and where to go next. And kids have a lot of informal knowledge that we don't have to directly teach them how to solve things, that we can build off of what they already know. So that was the premise that after I got my master's degree, went back into the school, was teaching 6th grade, and I was all, like gung-ho, I'm just going to give them a problem and see what they do. And you know what they did? Nothing. They stood there staring at me like, tell us what to do, right? Because they were so ingrained in being told what to do, and they didn't have a sense of numbers. Like one of the things that I always thought was so interesting, the research of cognitively guided instruction. I'm gonna have to write this down so I can get, and it wasn't this exact problem, but let's say, okay, I wrote this down so I can get it here. So they gave kids problems like 3 + 4 = box + 5, right? And you're trying to figure out what's in the box.
Yeah.
And there's an article that was published, I believe, in one of the NCTM journals about that research. And 1st graders were better at solving that problem than 6th graders. Like 100% of 6th graders got that problem wrong because they wanted to put 7 in the box. It's like they get ingrained through the way that we teach them that equal sign means the answer comes next. Yep. Right. So by the older they get, the harder it is to get them kind of out of their box of, well, this is, the way that the teacher has taught us. Right. So when I first tried to do more problem solving and problem-based learning with my students, it was very, very difficult because they've had so many years of they just wait and to be spoon-fed what to do and then work from there. So it took a lot for me to realize that for them to be able to be okay with attempting a problem, there was a lot of stuff that had to happen. And one of the big things that I saw that those kids were missing was just a sense of numbers. Like for them to approach some problems, they had to understand some stuff about numbers. Like they could add, subtract, multiply, and divide, but they really didn't understand what those things meant. Right. And a lot of us as educators didn't learn those things. Throughout my time that I've spent doing professional development, I've heard story after story of teachers saying, I just memorized my multiplication facts. I didn't know that it meant groups of. That 3 times 4 means 3 groups of 4. I just knew it meant it was 12. I didn't know what it was. So if I was to give a problem in context, right? And if a kid doesn't understand multiplication as you're working with groups of the same amount, then it becomes very difficult for them to wrap their brains around anything that's beyond just memorize it and do it, right? So I went on this journey, and that was kind of I went way down a path, but went on a whole journey of really figuring out what students needed to understand about numbers so that they could operate with them outside of the rules and procedures that we tend to teach them. Right? And that's a lot of that came from the research of cognitively guided instruction and Clements and Sarama, Arthur Baruti. Like, just I'm a researcher at heart. So even after I got my master's degree, was still like reading everything that I could, buying all the books. I have been a member of NCTM since my very first year of being a teacher, and get the magazine every month, their journal, just gobbling up anything that you can to learn about what's already out there. What are people already discovering about how kids think about mathematics? And my focus has been on number sense and how that impacts kids with their fluency. Because if we want kids to go beyond just those algorithms, right? We've got to set them up with a foundation of understanding numbers that allows them to work beyond those algorithms. If they don't have that, then they are kind of stuck with just an algorithm, because the algorithms require no number sense, no value understanding. All you need is single digit operation sense, operational skills, not even sometimes.
That is so true. I'm like you. I was a middle school math teacher, and I started off the same way. But it was when kids started asking me why, and I was like, "Oh, we don't really know exactly. So let me get back to you." And I would have these endless conversations with my mentor about why, and I learned so much from her. And she was a fairly traditional teacher, but she understood all the why, and we really dug into it. But I had a lot to learn until I started doing professional development, was when I really started to get more understanding of, I had plenty of procedures like you, and half understandings and partial understandings, and putting all those pieces together is a long time if you're an adult and didn't get to build it when you were a kid.
Right.
Well, it's harder to almost go backwards. And even when you think you understand something, you think you have some, ideas. Molly and I have been digging into like integers and that end of things for a while. And
there's not a lot of answers there.
Like you get to a certain point and then it's like, is this math in service of math? Like, but in doing that, and like in having these conversations and looking at research and like pulling, going through all the books and all of that, it more so reminds us of the things that we don't know about the things that we know. And I think it's okay. It's so hard in the field of education, math education specific, like to admit, what, I'm not exactly sure about that, because it's always been the subject that's not subjective, right? Like, so if you're an English teacher, you've not read all the books ever written. Like, so like you can say, oh no, I didn't read that book. And it's not
a stigma.
You didn't read that book. It's not the end of all things, or, or you don't, you disagree what genre this goes into, or there's a lot more debate. Whereas in mathematics, it was always like, no, they understand it's these things in this order. And so it makes it a lot more challenging to think about that switch. And and how you build that from the middle school, because that's been the conversation I have had all day with teachers is, that idea of, well, it would be easier if they came up with these skills to make
Right.
that switch.
Yeah,
And I'm like,
wouldn't
well, it would, but that's not what we're tasked with. This is where we're at. So what are we going to do about it?
Yeah, but it's so true. When you're talking about the kindergarten teacher, I have said so many times that I think every teacher should watch a kindergarten teacher teach, and not just math, but like any subject, and watch what they can do with the 20 kids in a class and rotating through stations and knowing where every kid is on everything and having checklists, and like they're phenomenal for the most part. It's unbelievable.
Yeah.
Well, let's get to your big question. Let's talk about how we build math fluency. What are your big
So I always like to start first, though, with making sure we're all on the same page of fluent and what does it mean to be fluent. I love Robert Kaplinski is a friend of mine, and he has this thing where he talks about going to Vegas, right? Like if you plan a trip to Vegas and you are going with a group of friends and we're all saying, we're going to Vegas. But one person's thinking, man, I'm going to lounge by the pool. I'm going to go to the spa. Somebody else is saying, man, we're going to Vegas and I'm going to be gambling the whole time. I'm going to be this. Somebody else is like, I'm going to go to all the shows. We're going to be eating. Like we all have different versions of what that means when we say we're going to Vegas. We're going to do a trip to Vegas. So it is always helpful to get on the same page, first of all, and then we can make a plan of how we're going to actually get there. So what do we mean by fluency? And I really love Susan Jo Russell's definition of this. She had an article called Computational Fluency. And the more that I have used her definition, like it just applies in any kind of fluency, anywhere in our lives. So I like to always have people think about like something in your life outside of reading fluency, math fluency. What is something that you feel like you are fluent in? And most of us have something in our lives, whether it's folding laundry, even as a mom of four. Like, actually, I hate folding laundry. I just put it in a clean pile. You guys take care of it from there. I am not
with
fluent.
you on that. Life skills, girls. Your laziness creates good workers in the future.
Yes. But whatever your fluent thing is, a lot of people are fluent with a musical instrument, a second language, riding a bike, driving, right? We've got something that we're fluent in. And so there are two things that most of us think of instantly when we think fluent. Like you can do it correctly. You get an accurate answer, you get an accurate note, you get an accurate word, whatever it might be. So accuracy is an essential part of being fluent with something. We also need to be efficient. We need to be fast with it, right? Whatever it might be. I talk a lot about, I used to travel a lot before I started doing online PD, and I would have Uber drivers or cab drivers before the Ubers were around. And, if they're a fluent driver, I want them to take the most efficient route to where I'm going, right? I don't want to have them take me on a $20 route when it could be a $5 route to where we're going. So it needs to be efficient, right? They need to be fast. They also need to be accurate. And unfortunately, in our education system, those are the two areas that we tend to assess. And so those are the two areas that teachers think are the ones that matter, right? We spend a lot of time trying to get kids to have the correct answer quickly. But that's only two pieces of the puzzle. If you are not also flexible, then you are not fluent. So let's think back to that cab driver or Uber driver. And if the most accurate, I want that person to get me to the right spot. I want them to be efficient. But if there is some kind of road construction or an accident on the most efficient route, that cab driver needs to have another way to get there, right? And hopefully that other way is not going to be the longest way to get there. We want it to be another route that is also still efficient and gets me to the right spot. So accuracy, efficiency, and flexibility, all three of those things need to be in place for us to be a fluent person at whatever your topic is, whatever the thing is. So I always tell people I'm not a fluent chef. I can follow a recipe to a T, right? I'm accurate. I'm efficient when I cook, but I am not flexible. If I don't have the needed ingredients, I can't make that recipe. I'm also not the person that can say, oh, if I just add a little bit of this, it would make it so much better. That's not me. Like, I have to follow a recipe. And so we have a lot of kids who are like that in mathematics. They can follow the recipe of the procedures and steps, and they look like they are fluent, but they are missing that flexibility. And so if we don't have all three, then we're not truly fluent. And so we want to build all three of those things for our students. And so to me, the missing piece that gets kids to that fluency is their lack of flexibility. We can get kids to that end product of getting a correct answer and getting it quickly. But there are so many kids who were like I was, who I could get that correct answer, but I had no flexibility. I couldn't come up with something, like I couldn't do math in my head. I always needed paper, pencil to do the algorithm, right? And if I didn't instantly know it, I really didn't have another way. I had tricks. I still to this day remember 8 and 8 fell on the floor, picked them up. They were 64. Right. And that was
a new one to me.
That was a rhyme that was taught to us that I remembered what 8 and 8 was. Right. But if I didn't have some of those, so like 7 times 8 has always been a tricky one for me, even as an adult. I am like, I know it's 50 something. And so then I have to figure out what it is exactly. It's always one that I'm like, because there's a lot of those like 52, 54, 56, all in that little range. And I always do it. So we want to have some kind of flexibility there, that if we don't instantly know it, then we have a way to be able to figure that out. And this actually came up today. Every Wednesday, unless one of my kids has some appointment or a sick kid or something, I've been trying to go into my youngest child's math class. He's in 3rd grade. And so after the math time today, the kids always go to recess at that time. And so I got to chat with her, and she was just talking about how she's really struggling. She does a lot of cool stuff. She uses a lot of Kathy Fosno's stuff, the Context for Learning. It's so fun to go in and sit in the classroom and just see these kids thinking. And she was telling me today, she's like, I gotta spend some time talking about test prep because the test is coming up. And 3rd graders, this is their first time doing the online testing. And she's just kind of struggling with some of that because she loves what she's doing there. But she's like, you know what? I know they're going to do great on it. And all she's like, I just got to teach them like how to even function in the, how to even do stuff, on the computer. And how to do like a multiple choice type problem, because they don't see those very often in the class. She's very problem-based learning, and fill in the blanks and things like that. So she's like, but she goes, I know that they're going to do great because I haven't taught them. You have to do, like, these are the steps and procedures. They're thinkers. And so she's like, I know that no matter what problem they're approached with, they can figure it out. They won't just sit there and be like, my teacher didn't teach me this. That I think back to a lot of my students that I had my first few years, and I know that they were so like that because they were so used to me spoon feeding them. And when they didn't understand, I was right there, like walking them through step by step by step, instead of asking questions and building their flexibility along the way. So as we get into that testing time and we're feeling a pressure of, have I taught my kids everything they need to know? You never will. You cannot teach them everything that they will ever need. Every year, there's always some chapter in the book that we never get to, right? But if we focus on building their flexible thinking, then no matter what problem they have in front of them, I mean, I'm not saying no matter what problem, right? Don't give them an algebra 2 problem for a third grader.
Yeah.
Don't take me wrong there. But, you know, their typical third grade type stuff, they can figure it out. If we have taught them to be flexible thinkers and problem solvers, then no matter what kind of a problem that they see, they can think through it. And that to me was the biggest part of flexibility, was that you didn't feel like you needed to know it all, you know, because you could figure it out. I always felt like if I didn't instantly know it, there was something wrong with me. And that's why I would shut down with those story problems, because I didn't instantly know it. And I wasn't a good thinker through problems. I was a doer of problems.
Yeah. So what are some ways that you recommend people work on that flexibility? This is lots of the work that we like to do with teachers, and we are 100% in your camp in terms of your definition of fluency. And that flexibility is the hardest one for, you know, teachers already learn how to do math efficiently and how to teach math efficiently, and then how to get the correct answer. That all comes with your college degree. But the flexibility piece is more mysterious for teachers.
Yeah. So I did prepare some slides. So I think it would be easier to share some of them.
Yeah, wonderful.
And I realized too that let's see, it doesn't do Keynote, so I have to try to find this real quick. Okay.
If you just hit share, I'll be able to put it in.
And of course, it's like uploading. It's sitting there uploading.
Oh yeah.
So while it's
why
uploading,
would it? It's not fluent yet, so
yeah,
it doesn't have the flexibility.
Yeah. But I can tell you my top 3 tips that I try to talk about anytime that I'm doing sessions and talking about flexibility. Number 1 is the visuals. If we aren't using visuals, then it stops kids in their tracks, because all they have are the symbols. And so once we attach visuals to any kind of problem, and that can be pre-made visuals by us, but it can also be, the more you are using those visuals, the more kids start to realize, I can make my own visual, right? Like we want kids to be able to use visuals. Okay, I'm going to flip through these. These were some of my notes. Okay, so the visuals are super key. And you can see the other 2 things in here that are kind of grayed out here, but we'll talk about them really quickly as well, but we'll get to them. So visuals. Stop directly teaching the strategies. Kids naturally develop strategies on their own, but yet our textbooks try to teach them step by step. Here's 5 different ways to do addition. And again, it's just rote procedures to them. And the way that we then help them develop those strategies. So don't get me wrong, I love having kids to have strategies. That's what flexibility is all about, is having strategies. So we don't directly teach it, but instead we build their number sense. And then the byproduct of them developing their number sense is they see these strategies naturally. Okay. So this idea of visuals, here's a common visual that kids have when they are trying to do multiplication, right? We teach kids that it's groups of. Well, this kind of visual makes kids count. There's no flexibility here. Like some kids might see some groupings, but even as adults, we got to count all of those. I got to count to figure out how many groups there are. And then I got to count how many are in each group. And because you didn't make that slide, you're probably double checking every single group to make sure it's the same amount, right? Even if you guys trust me, your students don't trust that it's going to be the same. So they're counting every single one of those dots. Kids have to count with that kind of visual. So even just attaching visuals isn't quite enough. I like to tell people we've got to use structured manipulatives and visuals. When you have a structure in place, it allows kids to see groupings. that they don't see. Like, this is the same amount of dots, but
Right.
how much easier is it with this visual than the past visual, right? They don't have to count. If they're familiar with 10 frames, they instantly know there's 6 groups. There's 6 in each because they see a 5 and 1 more. But then they can also use those visuals in some way to come up with a strategy. Some kids will still count every single one of those dots. They'll still count them. But some kids are going to group the 5s all together and then count the extra 1. Some kids are going to say, I see that there's 5 groups of 6, and I know 5 times 6, that top row is 30, and then there's just 6 more, right? All those strategies come about when we have some structured manipulatives or structured visuals, right? And it doesn't have to just be for multiplication. This happens as early as kids can start counting, right? We bring these blocks out, and guess what happens? Kids count every single one of those blocks to figure out how many it is, right? This is an image that I took. It's a screenshot. We were using an app to count how many there were. He counted the 6, the 7, then he went back and counted all 13. The same kid, I gave him this visual. Guess what happened? Instead of counting, now he's making a 10 because of the 10 frame. So the manipulatives and the visuals make a difference. And then right after this visual, I gave him this visual with the Rec and Rec. Same kid did a completely different strategy. He didn't make a 10 on this one. And he wasn't making a 10 because it was a lesson out of the book.
Right.
What happens typically is kids will make a 10 because we're doing a lesson about making a 10. But then when they're off on their own, they don't remember, and then they're back to counting, you know? So
right, but this is so interesting, Christina, because I mean, we work on all of these things, but to see them consecutively is really interesting, because you're right. Like, one thing that I think is really hard for some teachers to understand, and kids alike, is that sometimes your strategy is indicative of the kind of problem that you're doing, right? And even though these two problems are the same, because your manipulative or your visual is different, it inspires a different type of solution method. And I think it's fascinating. I love it.
Because you think about in many textbooks, they'll have like at this, like, so we're making a 10 was yesterday. And of course we've mastered that in a day, right?
Yeah,
our first time through. And then the next day is double plus 1. Well, you've done, which never made sense to me, like as a strategy. I'm like, I don't understand why we're teaching that. But this, like, when we look at it in this visual way and compare that, like, yes, then it makes sense that a child might do that as a strategy that works for them given this situation.
But also, Heidi, like, they can move on with this, right? So like if they can visualize the Rec and Rec in their head as they move on with problems, if they recognize that there are doubles plus 1, I mean, which is the idea of having any kind of visual, right? Like, I like
be able to conjure that up in our minds. And that's why I encourage the structured manipulatives, because to be able to conjure up 7 plus 6, like, even as adults, we can't visualize that. Our ability to visualize an amount ends about 4 or 5, unless it's structured in some way. And so I can picture 6 plus 7 on a Rec and Rec when I close my eyes because of the color switching, or I can picture 6 plus 7 using my fingers because 7 looks like this and 6 looks like this. I can picture 6 and 7 in a 10 frame, but I can't picture just 6 random cubes and 7 random cubes and then be able to put those together, right? And so the structured manipulatives leads to be able to hold those quantities in your mind and be able to use them later as well. But the other point I like to make too with this sequence of pictures here is that the model does not determine, like, you can't force a kid to use a model in a certain way, right? Like, a lot of lessons we'll see where it'll say, okay, we're using a 10 frame, so you have to fill that 10 frame. Well, what if a kid doesn't want to? What if a kid saw doubles in the 10 frame? Let them use doubles plus 1 in that 10 frame. You know, in the Rec and Rec, I could force kids and teach them make a 10, get all the beads pushed over on that top row before you push any on the bottom row. I could teach them that, but you shouldn't be. Let the kids use those tools in a way that makes sense to them. But our textbooks will try to teach it in a way of basically a procedure. You put the first amount into your 10 frame, then you fill your 10 frame, and then you look at what's left over, you know, like
I know, because
procedurally.
For me, when I look at this, I wouldn't do doubles plus one. I would be seeing all the red and all the white.
Yeah, that's what I thought too. That's what I saw. I like to make a 10. 10s are so easy for me. But this kid, he didn't, even though the slide before that, he made a 10. So what was different? You know, I don't know. And that's what he said, like, that's 6 and go down. That's one more. You can see his line.
I know.
Down.
I love that.
Yeah.
I love it. It's great.
That's crazy. Okay. So that does lead to stop teaching the strategies. Stop directly teaching it. Give kids opportunities to play in those strategies, right? You don't have to teach it to them. Just give them some visuals and ask them how many are there. You are going to still have kids who will count every single item there. You're going to have kids who will group it in this way and this way and this way. But it's just cool to see, because that is what is making sense to them at the moment, right? And so as you move forward, you can put it into things like doing number strings. So this is a string you could do with upper grades. I mean, you could cut this off whenever you want to, but this is one I love to do with fractions and mixed numbers with older kids. And you start with things like 9 plus 7 and the whole make it friendly. I don't call it make it 10. I call it make it friendly, because make it friendly lasts even as you get into working with fractions. Right? I'm not making 10. Even when you get to the decimal version there, the second one, some kids are like, we didn't make 10, we made the next whole. Like I wanted to make 4 because that would be so much easier. So it's all about making it friendly. And you can do strings with kids. I'm not directly teaching them, chunk off this amount, move it over. I'm using what they already know, how they've solved addition problems in the past, and then connecting it to how they could use that with problems that they may have not thought about yet. Okay. And you can do that even with visuals. Here's one of my favorites for, one thing that blew my mind was with multiplication. I did not learn this way. As you know, I was very much just the memorizer. But if you know 10 times something, that helps you with 5 times something. Right? So in these visuals, I'm showing 10 groups of 4 and then 5 groups of 4, 10 groups of 3, and then 5 groups of 3. And so you're walking them through, like, what do you notice about how many we have and how many groups in the product and all of that stuff. So you can do number strings visually to help kids kind of come up with that. That's a strategy that now our textbooks try to directly teach kids. They 10 times something and then have it, and it will give you what times 5 is. Let them play and discover that. Use visuals, do number strings. That helps kids be able to do that. And then that last one of focus on number sense, build their number sense, and then these strategies happen. Here is just all that it takes for one strategy. Here's 18 plus 27. And a typical strategy that our textbook tries to have us teach kids is to, make it friendly or make a 10, whatever you want to call it. So they, chunk off 2, and now the 18 makes a 20, and we've got 20 and 25. But think about everything a kid needs to know to really understand that strategy. That's why I think parents are so frustrated. Like, just teach them the algorithm. It's easy. It works every time. There's a whole lot that you got to know about 18 and 27 to be able to use that strategy or any strategy beyond the algorithm, right? So there's so many parts. I talk a lot on my blog about these number sense concepts. So if you're not familiar with these number sense concepts, you can just Google my name and number sense, and stuff will come up all about this. But there's so much that goes into it. So that's a strategy for multi-digit addition. Here's a popular one for, single digit. and the make a 10 and everything that kids are basically asking themselves and trying to figure out as they're trying to develop this strategy. There's so much that goes into it. And then here's an example for multiplication. We try to teach kids, sevens are, sorry, that's my alarm to remember to go pick up a child, but I don't have to pick up a child today. I arranged it, but didn't turn off my alarm. So, we try to help kids understand that sevens are sometimes difficult to multiply by. So you could chunk it and think of 5 groups and 2 groups and then put those together. That's a strategy that our textbooks are now trying to directly teach kids. But if they don't understand all of this stuff, they will never do it. They might do it for that lesson, but then that's where we get kids who later, it's like, I taught you this. Yeah, we did it for a lesson, but it didn't, it didn't resonate with me because I didn't understand all this other stuff that was happening there. I could do it for the moment, but I'm really don't have the flexibility to be able to really understand those things. So again, lots and lots of visuals, but to take your visuals a step further, use some structure to those so that kids can see some groupings a little bit easier and get beyond the counting phase. Don't directly teach the strategies, provide them opportunities to talk about those strategies and share how they are thinking about it, and start focusing on building their number sense. And building number sense is a whole big topic. I've got full 15-hour courses all about building number sense. So that's a big, hairy thing, but I have a lot of free videos on my website all about those number sense concepts and what they are, how we build them for kids and all of that stuff. So people can dig into that in other places if they're interested in that one, but that's it.
Awesome. Yeah. That brings us into how we can learn more about you. And I know you referenced, your website. And so we're going to put that up here in a moment for those of you who may or may not be familiar.
Right.
So that is one. But also we know that you have your big virtual summit coming up. So tell us a little bit about that.
So the virtual summit was started because I started doing online professional development before we were forced to do online professional development. I think I'm going on 7 years of doing online PD and 6 years of the virtual math summit. So I was doing online PD and realized people need to hear from more than just me. So the virtual math summit was a way to bring more voices and more ideas into online PD. And so this year we have 31 sessions, all completely free for 10 days that you can come watch. It's just virtualmathsummit.com to get registered. It's over 2 days. So it's February 26th and 27th, all online, and they're all pre-recorded. So as soon as they get released, so they're released at a certain time because a lot of the presenters want to be there and interact in the chat. But as soon as they get released, you can watch them at any time that you want that works for your schedule, because it's, crazy being a teacher. So you're doing it on a weekend, but then if you can't watch them all, you've got nights and any other times that you can just hop on with your phone and your earbuds when you're taking a walk or working out or driving to school, that you can listen to the sessions. So
last summer I did a lot of walking to sessions for sure.
Yeah, we've got, I think right now, almost 14,000 educators signed up for that. So it's, we get a lot of people coming to that, which is pretty exciting. And from all over the world, we hear, we get to interact with educators from everywhere, all countries. We have them from all over the world who will come and interact in the chat. So it's a pretty fun way to connect with teachers outside of your school too.
Neat.
Yeah, no, it's a great resource that you provide, every year. So we always look forward to that.
Yes, for sure. And they can reach you here, right?
Yep. I'm at Build Math Minds and buildmathminds.com. I do a podcast every week, and I have a lot of video trainings as well on the website. So there's just trainings area, resources, everything on the site. So everything's housed there.
lots of good stuff on there. So hopefully people will head on down to your website. There's so many good resources that I've used with teachers. So thank you so much for being here. Good Lord, being here with us tonight. This has been great. I loved your slides and I love the visuals. So
thank you so much for asking me, and just honored to be part of the Math for All group this season. So thank you so much.
We really appreciate it, and we'll be watching here in the next couple of weeks.
That's right.
The Math Summit. So
that's right. Yeah.
Thanks.
All right. Thanks. Oh, that was so good.
I always look forward to
visual.
that.
You know me, I love visuals. So getting to see the student work with visuals, I eat it right up. All right. So we're taking a bit of a break because here in Massachusetts, we have February vacation next week, which is really not had in most of the country. So
but we're so thankful.
I know, right. Our teachers are starving for a break. So we will be back on March 9th with Bethany Lockhart Johnson. We're super excited to talk to her. And that's it, right, Hype?
Yep. So we will talk with you later. And until then, we hope that you keep creative, curious, and inclusive. Math for all. Thanks and have a good night.
Thank you.